stars in the universe. Celt 9 is at least twice as large as the Sun and nearly twice as hot. Hot giant stars like this tend to burn through all of their hydrogen fuel very quickly, and so they don't live for very long, at least on astronomical timescales. Stars like Celt 9 typically only shine for less than a billion years. Compare that to our Sun, which is expected to live at least 10 times as long. Because A-type stars are so short-lived, they are also relatively rare, comprising only 0.6% of all the stars in the Milky Way. But age and size are far from being the strangest things about the star. The strangest thing is the planet that orbits around it. Extrasolar planets, planets in orbit around stars other than our Sun, are not themselves unusual. To date, astronomers have been able to confirm nearly 5,000 such exoplanets, but the fact that an exoplanet has been detected around a star as big and as hot as Celt 9 is unexpected. Giant stars like this burn so hot and so quickly that they create an environment that is hostile to planetary formation, and yet one planet, Celt 9b, has been found in orbit around the star. Celt 9b is a gas giant planet, much like Jupiter, except that it is 2.8 times as massive. Jupiter orbits the Sun at an average distance of 484 million miles, which is a little more than 5 times further than the Earth. It takes 12 years for Jupiter to complete one orbit. On the other hand, the closest planet to the Sun in our solar system is Mercury, circling the Sun once every 88 days in its 29 million mile wide orbit. Celt 9b, despite being larger than Jupiter, orbits its star far closer than Mercury, 11 times closer. The planet's orbit has a radius of only 3 million miles, but because the star itself has a radius of more than 1 million miles, Celt 9b circles a mere 2 million miles above the surface of its star. At that distance, it is able to complete a full orbit in less than 1.5 days. If an astronaut could visit this planet, they would see a blinding orb of light 70 times larger than the Sun appears in our sky. But this gargantuan sun would not rise nor set. Celt 9b is so close to its parent star that it has become tidally locked. Tidal forces acting between the planet and the star are so great that the planet's orbit and rotation have become synchronized, forcing one hemisphere of the planet to constantly face the star. This is the case within the Earth's moon, and why we can only ever see one side of it, because Celt 9b is tidally locked within its star. One side of the planet is trapped in constant blinding daylight, while the other side is trapped in eternal night. Bathed in never-ending sunlight from the nearby star, temperatures on the daylight hemisphere skyrocket to an unthinkable 7,800 degrees Fahrenheit, making it hotter than more than 75% of actual stars in our galaxy. The temperatures on Celt 9a are well above the melting point of any known material. Traces of iron and titanium vapors have been detected in the atmosphere of Celt 9b. At these temperatures, the molecular bonds between the atoms are torn apart. It is so hot that the entire planet would glow a dull red, like a burning ember in space. Remarkably, Celt 9b's extreme temperature is only one of this planet's bizarre attributes. The planet orbits very close to its star, close enough to become tidally locked, as we mentioned, but any closer and the planet would pass the star's so-called Roche limit, beyond which the tidal forces are so great that the planet would be torn apart. Because Celt 9b is just outside this Roche limit, and just because it's being constantly bombarded by its intense solar radiation, the planetary atmosphere is being blasted away at an incredible rate. As many as 12 million metric tons of material are blown off the planet into space by the solar wind every second. Every 10 million years, it will lose an entire Earth's worth of mass. Celt 9b might almost resemble an ultra-massive comet, with a bright tail of gas stretching out behind it for millions of miles. In a few billion years, the planet might even evolve into something different. It is theorized that the gaseous atmosphere will someday be lost entirely, leaving behind only the dense, naked core. Members of this theoretical class of planet are called Cathonian Planets. As of yet, there is only one probable candidate with this new classification, the recently discovered TOI 849b. This planet is roughly Neptune-sized, nearly 3.5 Earths across. However, its mass is 40 times that of Earth, suggesting a density much higher than a typical gas giant. The probable explanation is that TOI 849b is an abnormally large rocky planet. This would be the most massive rocky planet ever discovered. Such a large object would have a very strong gravitational pull. Astronomers would expect it to begin gathering a thick, gaseous atmosphere, eventually growing to the size of a gas giant planet. The theory is that TOI 849b was indeed a gas giant planet at some time in its past, but that its atmosphere has been completely torn away by solar radiation. All that remains is the dense exposed core. TOI 849b's host star is also relatively old and evolved, lending even more credence to the theory. Yet another peculiarity regarding planet Celt 9b is its orbit. but Kelt 9b's orbit is inclined by a staggering 86.7 degrees, nearly perpendicular. Planetary systems are believed to form out of a proto-planetary disk, a disk of leftover gas and dust that orbits around a newborn star. The dust eventually collapses down to form planets, moons, asteroids, and everything else. The principle of conservation of angular momentum would dictate that the rotation of both the disk and the star should be roughly aligned. That is why all the planets in the solar system lie roughly along the same plane. The fact that Kelt 9b is in a polar orbit around its star seems, at first, to defy the laws of physics. Astronomers can't say for sure exactly how this planet's orbit came to be so extremely inclined. It's possible that something came along to perturb the protoplanetary disk during formation. Either that, or something knocked the star on its side, making the star the one that is misaligned, not the planet. Another theory involves tidal interactions and orbital resonances, causing angular momentum to be exchanged between the two bodies and slowly ramping up the inclination of the planet's orbit. How Kelt 9b got to be in an orbit so close to its parent star at all is also somewhat of a mystery. Although it is one of the very hottest known exoplanets, Kelt 9b is perhaps surprisingly not alone. It belongs to a class of exoplanet known as hot Jupiters, gas giant planets with very short orbital periods. Astronomers have already found a few hundred such hot Jupiters. This is actually completely expected, given the methods we use to find new exosolar planets. One method is to watch the star's position. A planet's gravity will tug slightly on the star, causing it to wobble back and forth. The bigger the planet, the bigger the wobble, and therefore the easier it is to detect. We can also watch for a temporary dip in the star's brightness, caused by a planet passing in front of the star during the planet's orbit. So, our exoplanet detection methods are biased towards finding hot Jupiters, large planets that orbit very close to their host stars. Still, that doesn't resolve the question of why they exist there in the first place. Astronomers still aren't quite sure. According to our current understanding of planetary formation, the regions closest to the stars are far too hot for volatile, lightweight elements, like hydrogen and helium, to condense. Gas giant planets are made primarily out of these lightweight gases, and so it should be impossible for them to form close to their stars. There are two prevailing theories. The first is that they formed exactly where their present orbits are. This would be unexpected, but it may be possible for a rocky core a few times the mass of the Earth to form close to the star. Its gravity may then be strong enough to hold to a tenuous gaseous envelope for long enough for it to eventually evolve into a fully gas giant. The second, more likely theory is planetary migration. We tend to think of planets as being fixed in their immovable orbits, like trains on an unchanging track. But that isn't necessarily true. Gravitational perturbations and interaction between planets can cause the orbits of the planets to change, sometimes very drastically. Our solar system has been around for 4.5 billion years, so the planets have all had a chance to find steady, stable orbits. But that wasn't always the case. Billions of years ago, the solar system would have been a much more chaotic place. The constant gravitational tug-of-war between the newly forming planets caused orbits to shift and change constantly, migrating inwards or outwards, seeking a more stable position. This mechanism is the most probable culprit for creating hot Jupiters. A gas giant planet forms far away from the parent star. Gravitational and tidal forces then push the planet inward until it stabilizes in a narrow, short-period orbit close around the star. The ultra-hot gas giant planet Kelt 9b is one of the strangest, most extreme worlds that we've ever discovered. Further studies and new advances in technology, like the soon-to-be-launched James Webb Space Telescope, might tell us what else Kelt 9b is hiding within its hellish cloudscapes. Thank you for watching Matter. Make sure you like this video and subscribe to the channel to discover more about strange alien worlds like this one.
How did our particular universe, the one that started 13.8 billion years ago, how did that start?
Ever since thoughts began to exist in the minds of humans, our species has been asking themselves the same question we are asking today. How did all of this come to be?
One model is the inflationary multiverse, this eternally inflating multiverse in which big bangs are happening all the time. They've been happening all the way infinitely far back into the past and will continue.
One of the most fascinating developments of modern science seeks to explain how our universe began 13.8 billion years ago. The leading theory about the origins of our universe hinges on an explosion the size of which has yet to be seen again. Scientists call this theory the Big Bang. This theory says that the Big Bang happened in an instant, and everything that exists in our universe came into being in that singular moment.
So Stephen, everyone wants to know, what was around before the Big Bang?
Nothing was around before the Big Bang.
Please tell me how something can create itself out of nothing. the rabbit out of the hat, without a hat, without the rabbit, and without the magician. And he paused for a moment and he looked at me and he said, well, it just does.
Explosions occur constantly throughout our universe due to the volatile nature that exists within it. But none have been close to the size of the Big Bang. But studying other explosions, especially some of the bigger ones, may help astronomers shed more light on our universe. Astronomers are always on the lookout for the next significant explosions in order for them to gain a better understanding about the nature of our universe and how it functions. Astronomers often look out into space in order to find new features of the universe that have yet to be discovered and documented using a variety of tools at their disposal. During one of these searches, astronomers are looking towards the Offiakis Cluster. This cluster is a giant cluster of galaxies around 390 million light-years away from Earth. A galaxy cluster is one of the largest structures that we have found in our universe. They can be made up of tens of thousands of galaxies, clouds of hot gas, and are filled with the dark matter between the galaxies, helping to provide the huge amount of gravity required to hold these structures together. Astronomers use the X-ray telescopes like the NASA's Chandra X-ray Observatory, among others around the world, to collect data from the radiation emitted from the Offiakis Cluster in order to learn more about it. While looking through the data collected, the astronomers noticed something very large and unusual near its center. In the middle of this gigantic galaxy cluster, there was a massive hole in the hot gas that hangs around the cluster filled with radio waves. Astronomers began to compare this hole to craters left after a large volcanic eruption, like the one that rocked Mount St. Helens in 1980. Upon further investigation, astronomers reached the conclusion that this crater was in fact caused by an explosion. Not only an explosion, the largest explosion that scientists have ever found inside of our universe. When astronomers say that this explosion was huge, they mean it. It was absolutely mind-blowingly big. Much like the explosion of a volcano leaves a massive crater behind, this explosion ripped a cavity into the surrounding cloud of hot gas. The void it created measures over 750,000 light-years across. That makes this cavity so large that 15 Milky Way galaxies can fit side by side in a line across the diameter. Astronomers had a hard time imagining how much energy would need to be released to create a hole this big. Nothing that they have found before measured anywhere close to the size and strength of the explosion that formed this crater. They eventually found that the amount of energy released in the explosion was nearly 5 times larger than the previous record holder for largest explosion. It turns out that they calculated the amount of energy, and it would require 5 times 10 to the 54th power joules of energy to blow this big of a crater into the gas cloud. Explosions within galactic clusters is nothing new for astronomers. From what they have found, many galaxies have massive black holes in their centers, and wherever black holes are found, there is sure to be something of interest to astronomers. There are a few objects that exist in our universe that can cause explosions inside of galactic clusters. These objects include massive stars going supernova at the end of their lives. Another one of the most common sources of explosions within galaxy clusters are black holes. Black holes are known to devour anything that gets too close to them. But did you know that they can also spew out huge amounts of matter and energy if the conditions are right for them? And when black holes release their energy, they will spew huge amounts of matter and energy out into space. But the more common explosions that astronomers find in the galaxy clusters are hundreds of thousands times weaker than this explosion was. So, what caused an explosion this big? One leading theory as to what caused this explosion targets a supermassive black hole at the center of one of the Offiakis Cluster's many galaxies. A lot of larger galaxies have black holes that are so large that they become classified as supermassive black holes. These supermassive black holes can get as big as 21 billion times the mass of our Sun. Black holes this large would fill up nearly half of our entire solar system by itself. If a black hole of a somewhat similar size lived at the heart of one of the Offiakis Cluster's galaxies, and the conditions were just right, it could have created an explosion large enough to create the damage that astronomers can see. Black holes in the center of galaxies are often surrounded by giant clouds of hot gas and plasma that are slowly being pulled towards it. But the gas and matter being pulled into the black hole can get redirected, and it will begin flowing together until a massive jet spews all of the matter out into space in a powerful, high-energy stream. A massive explosion occurs when these high-energy jets strike the clouds of hot gas and plasma. The collision between the jet and the black hole and the gas cloud could cause an absolutely gigantic explosion to happen. The explosions are so large due to the sheer amount of energy that builds up in the black hole and the gas clouds that swirl around them. When the conditions for them to release all the built-up energy are right, nothing can stop a black hole from spewing massive jets of energy out into the cosmos. When astronomers first detected this explosion, it was already over. But in the timescale of the universe, it may have happened in the not-too-distant past. Astronomers do not seem too concerned about the dangers that these explosions pose to us on Earth. Explosions this big do not happen often. In fact, some astronomers have hypothesized that an explosion that can be considered large on a cosmic scale only occurs about once every 100 million years in a galaxy like the Milky Way. Not to mention that nearly every galaxy is far enough away from us that an explosion there will most likely not cause damage to us on Earth. The Offiakis Cluster itself is far enough away that the destructive force from this explosion would not have come close to affecting us if it occurred today. While astronomers do not know why this explosion was so big, they believe that it occurred at a very slow pace and could have taken a period of hundreds of millions of years to happen. While this is the biggest explosion since the Big Bang that astronomers have found, humans have yet to explore the vast majority of the observable universe. Who knows what is left out there for scientists to find? Every time something new is discovered, our understanding of the universe gets a bit better and a little more complete. Astronomers may find another explosion that is magnitudes bigger than this one, or they may find that this is the largest explosion that has occurred since the Big Bang. They can only keep searching through the cosmos hoping to find the next big discovery that helps science answer another one of the many questions that are currently unanswered. Do you have a favorite mystery that science has yet to answer? If you watched all the way to the end, we want to say thank you for watching, and if you enjoyed this video, please feel free to hit the like and subscribe button so you won't miss any of our future videos.
The sun, which has been shining down on the Earth for the past 4.6 billion years, is what makes all life on our planet possible. The Earth's position around the sun is so highly fortuitous, any closer to the sun and the seas boil away, becoming far too hot for life to exist. Too far away and our world becomes a barren, frozen wasteland. Our planet and star have created conditions that are perfectly suited for life, as we know it. But imagine life somewhere out there, on a world completely alien to us. Imagine life on a world with not one, but 3 suns. You're watching Matter. In this video, you'll learn about the planet that astronomers think is hiding inside a solar system with 3 suns. 1,330 light-years away, just off the shoulder of Orion, lies the star system GW Orionis. The system is part of a young stellar nursery, a relatively dense region of space where new stars are being created. Our own sun is about middle-aged, already more than 4.5 billion years old. But the GW Orionis system is hardly a newborn, possibly less than 1 million years old. The system is so young that it probably hasn't even evolved into stellar adulthood yet. The stars of GW Orionis are classified as T Tauri stars, an unstable and violent phase where the core becomes hot and dense enough for ongoing thermonuclear fusion. When this happens, the stars will enter the main sequence, the stable phase where a star will spend the vast majority of its life. Aside from its age, the young GW Orionis is fascinating to astronomers because it is a trinary star system, a system with 3 stars. The first 2 components of the system, stars A and B, are separated by a distance of around 116 million miles, which is only 1.25 astronomical units, or AU. 1 AU is defined as the distance between the Earth and the Sun. Both stars are also somewhat larger than our Sun, star A being 2.75 times as massive and star B 1.65 times. Because the 2 stars share a similar mass, they actually circle each other in a binary orbit. Their orbits are centered around their common center of mass, which lies about 1/3 of the way between star A and B. They complete one shared revolution once every 241 days. The third star, GW Orionis star C, orbits much further away from the inner binary at a distance of 854 million miles, just shy of the distance between the Sun and the planet Saturn. Star C is the smallest of the system at only 88% of the Sun's mass. It takes 11 years and 7 months for star C to complete one orbit around the AB binary. This configuration of orbits, a close binary pair with a third more distant companion, classifies the GW Orionis star system as a hierarchical triple. Such systems are probably relatively rare in the cosmos, since multiple massive bodies in the same system often lead to unstable and chaotic interactions. But this distant trio of stars gets even more peculiar. The entire system is surrounded by a wide flat disk of gas and dust, known as a protoplanetary disk. This sort of disk would have once surrounded our own sun, but the material was eventually cleared away as gravity caused it to collapse down to form the planets, moons, asteroids, and comets that make up our solar system. Because GW Orionis is still very young, it hasn't had a chance to shed its protoplanetary disk. It's still in the middle of the process of planetary formation. Astronomers have seen plenty of protoplanetary disks surrounding other stars in the galaxy, but none of them are quite like this one. First, astronomers would expect the dusty disk to be aligned with the plane of the star's orbit, but it isn't. Instead, the circumstellar disk appears highly inclined with respect to the central trinary, perhaps as much as 45 degrees. On top of that, GW Orionis' disk isn't much like a solid disk at all, but instead divided up into 3 concentric rings, one inside the other like a set of cosmic nesting dolls. The outermost dust ring extends for nearly 340 AU, or more than 30 billion miles, making it the largest known ring of protoplanetary dust. The gaseous part of the disk stretches out even farther, to 1300 AU, which is more than 30 times the size of the orbit of Pluto. The 3 massive rings are all out of alignment with each other as well as with the central stars, so that each ring is inclined 10 to 20 degrees away from the one next to it. And between the central and middle dust rings, there's also an odd gap, nearly devoid of dust and gas. This gap occurs at a distance of about 100 AU from its triplet suns, cutting so deep that the inner and outer rings are able to rotate independently of each other. Astronomers have lots of questions about what is happening inside the GW Orionis system, and there aren't a lot of answers so far. The first theory was that as the 3 stars spun around each other in their complex orbits, gravitational torques between them worked to tear the surrounding protoplanetary disk apart. Dr. Stefan Krauss and his team at the University of Exeter have been using computer models and simulations to see if this explanation, the so-called disk tearing effect, is even possible. The answer is, sort of. Alison Young, another member of Dr. Krauss's team, says, "There have been a number of theoretical studies on disk tearing effects, but this is the first direct evidence of effect occurring in a planet-forming disk. This demonstrates that it is possible for such disk to be warped and broken, and raises the possibility that planets could form on highly inclined orbits around multiple star systems." However, as exciting as this answer is, it isn't entirely complete. While the simulations do show that it is possible for a triple star system to throw a protoplanetary disk out of alignment, it still isn't enough to explain the unique 3-banded structure of GW Orionis, or why there is a distinct gap in the ring of dust. Dr. Nienke van der Merel and her colleagues conducted a study using the Atacama Large Millimeter Array to try to get a better look inside GW Orionis. She and fellow researchers offer an alternative theory to explain the strange nature of the system. A Jupiter-sized planet, or possibly even several planets, are responsible for clearing out the gap in the system's ring of dust, and for tweaking the disk out of alignment. Dr. van der Merel said that our simulations show that the gravitational pull from the triple stars alone cannot explain the observed large misalignment. We think that the presence of a planet between these rings is needed to explain why the disk was torn apart. The clouds of dust and gas that surround the trinary star system obscure much of what is happening within, and so it'll be difficult to locate their proposed planet. But that won't stop astronomers from trying. More studies are already being planned for GW Orionis in the future to try to get a glimpse of this hypothetical new world. If it's true that there is a planet or planets in orbit around GW Orionis, it would be the very first circumtriple planet, a planet orbiting around 3 suns, ever discovered. Such a rare, unique system would become the holy grail for astronomers, offering valuable new insights into how planetary systems grow and evolve, and revealing unanswered truths about our infinite cosmos. Thank you for watching Matter. If you enjoyed this video, be sure to give it a like and subscribe to our channel to learn more about fascinating new space discoveries like this one.